Okay, hi guys. So we'll be continuing on seeing some more examples on Perkins reaction. Okay, so let's get started. So we have something like this. Okay, we have PHCHO. Okay, and this is again passed on in anhydride, again in presence of acetate. Okay, Na, and then we are passing obviously S3O plus, and we are heating it. Okay, so what would be the product? So obviously we actually remember the form P double AUA, which is Perkins aromatic aldehyde to unsaturated acid. Okay, so will this compound react with this the reagent? No. Why? Because this is not aromatic aldehyde. With this compound react? Again no. Why? Because this is not aromatic aldehyde. So what would be the product form at the last? Product form would be in the first step would be, or after this Perkins reaction would be, we'll be getting something like this product. Okay, and from this product again we would be passing on S2 and PDC. So it will actually act on this unsaturation and will actually convert this unsaturation into a simple single bond. Okay, and then if we pass on SOCl2 and then we are passing AlCl3, then what will happen is obviously this acid would be converted into acid halide. So as a result we'll be getting something like PHCH2 CH2 C double bond OCl, and on this Cl again then in presence of AlCl3 what will happen is if we draw it something like a benzene ring. Okay, after AlCl3 presence we'll be getting that this. Okay, first let us draw C double bond of Cl here, and then this will be getting converted in presence of AlCl3. Fiddlecraft alkylation will take place. Okay, and we'll be getting that this carbon atom would be attaching on this carbon atom. So as a result 1 2 3 4 5 member ring would be formed. Okay, with double bond O here. Okay, so this would be the final product. Okay, next let us see some more examples. So we mentioned about Ziegler-Natta reagent, so we'll be seeing reactions on the same. So first let us see what happens when NCH2 double bond CH2 is passed on Ziegler-Natta reagent, which is R3 Al plus TiCl4. Okay, then we'll be getting this product. This is ethene, and the polymer formed from the ethene would be ethylene. Okay, so this is nothing but Ziegler-Natta catalyst. Okay, which is a heterogeneous catalyst. Okay, so you might be wondering what is a homologous catalyst then, or homogeneous rather, not homologous, homogeneous catalyst. So example of homogeneous catalyst is Williamson's catalyst. Okay, Williamson's catalyst, and the example of Williamson's catalyst would be this PH3P whole thrice and then RHCl. This is example of homogeneous catalyst. We won't be going into the intricacies of a homogeneous catalyst and a heterogeneous catalyst, but just in any examination or in any multiple choice question you have been asked example of homogeneous catalyst, then in the scope of the syllabus of JEE, this is homogeneous catalyst and this is an example of Williamson catalyst. Nothing above this would be asked in any of the competitions. Okay, now let us actually see another topic, which is intermolecular forces in biomolecules. Okay, intermolecular forces in biomolecules. So first is elastomers, then fiber, then C, thermoplastic polymer. So this is the classification, okay, of intermolecular forces in biomolecule. This is classification. So we can find elastomers, fibers, thermoplastic polymers, and thermosetting polymers. Finally, thermosetting polymers. Okay. So let's see the examples of each classification. So the examples of elastomers or A category would be Buna S and Buna N. Okay, and we can also have natural rubber. Okay, then let's see examples of fibers. So fibers are strong intermolecular forces, like if we have something like this, and H here, okay, and or we can say something like this compound as well. Okay, so it is strong intermolecular forces. Okay, then let's see now the examples of thermoplastic polymers. Okay, so forces between elastomers and fibers. Okay, so let's see. So forces between polythene, orlon, polystyrene, or rather polystyrene, PVC, Teflon are all examples of thermoplastic polymers. Okay, and finally the thermosetting polymers. So intermolecular forces are highest in thermosetting polymers, so they are unbreakable. One of the characteristic of thermoplastic polymers is they are unbreakable. Examples are obviously bakelite and resin. We have seen the structure of bakelite. Okay, another is resin. Okay, so if we actually compare the intermolecular forces, so you have to just tell me the order of intermolecular forces in these compounds. One is bakelite, okay, then we have PVC, and then finally we have Buna N. Okay, so obviously this is elastomer. Okay, this is rather thermoplastic, and finally this is thermosetting. Okay, so the order would be nothing but this. Okay, so elastomer of thermosettings are more uh, are having more strong intermolecular forces than thermoplastic, which in turn has more intermolecular forces than fibers, which in turn has more intermolecular forces than elastomers. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing uh, the last topic, or a last concept, or rather a summary of all the concepts which we discussed as a part of this series of video lectures on organic chemistry and in the previous lecture. So that would be the last concept which we will be dealing as a part of JEE syllabus. Okay, so till then, good luck and goodbye.